Hello, welcome to my YouTube channel. My name is Joshua Skanika and I'm known as Inorganic Tutor. I'm an engineering student at the University of Zambia. I'll be taking you in CEE 2219. Yeah, so if this is your first time to visit my YouTube channel, please kindly subscribe to avoid missing out the videos which I'll be posting. Okay, so let's go to the main stuff. So today I thought of just going through a practice question on force vector. Yes, which is probably somehow the first topic in statistics. Okay, so without wasting much of your time, let's go to the main stuff here. Okay, so before we do any practice question, it is important that you have the background of what is behind that topic. Okay, so I'm going to start with the basic. Okay, so go over what scalars are, what vectors are, and everything you need to know about these vectors. Okay, so here's the thing. So we're saying what are scalars? What are scalars? Okay, and vectors. So this is the basic idea which you need to understand before you do anything on this topic. Okay, so what are scalars and vectors? So I'm sure from grade 12 you understand what scalars and vectors are. So here we're just trying to polish up you understand much more. Okay, so we discussed that scalars, these are just quantities which can be positive or negative, but can only be specified by by the magnitude. Those are what we call scalars. And examples which we can give on scalars, scalars. Examples which we can give as mass. So saying mass. 2, we can give length. Okay, we also have time. All those things which have no direction. Okay, so we're saying 3. 3, we are saying time. Okay, so let me end on 4, which I can say temperature. Okay, so these are what we call scalars. Okay, so these are scalars. What about vectors? What are vectors? Okay, vectors. So here vectors. Okay, so vectors can be defined as quantities, those quantities which have both magnitude and direction. So those quantities which have both magnitude and direction. What do we mean by magnitude? Magnitude is simply the length of a given okay, let me put it in this way, just a minute. Okay, so you've been given this is a force, or let me say maybe it's a displacement. Yeah, you've been given this one and the length. Okay, so you've been given the length to say this arrow has a length of what, maybe 12 meters. So this is 12 meters. So now when we say magnitude, we are referring to this value. This is the magnitude. Okay, so in simpler, we're saying the length of this arrow. Okay, so what do we mean by direction? Since we said vectors, those quantities which have both magnitude and direction. What about the direction? So the direction is simply the angle. Okay, so on this topic you'll be referring to as the angle. Okay, the angle between the reference axis and the same force. Okay, so let's maybe I give an example even on this one. Okay. Like this. Let's consider this as the x-axis, right? This is the x-axis. Then we say, okay, let's consider this our ground force. Okay, so let's consider that our force is coming in that direction. So this is our force. Okay, so that is our force. Now this force, as you can see, it is at an angle. Okay, from the reference axis. So the reference axis, I mean this one. Okay, is at an angle. So that is the reason why we say if a vector is that quantity which can be specified by what? Magnitude and direction. So the direction is this one. Yeah, so the direction is this one. Then the magnitude, it is just simply the length. Okay, the value instant. So this part is also important. You need to know that this is the halo. Yeah, halo edge. You can say that. It's okay. So this is the halo edge, also known as the sense. Okay, so this is the sense. Now the examples which I can give on this one. So let me just erase this part. Okay. So the examples which you can give on vectors, we can give force. I'll use the one which will be being used most often. Okay, so 2, we can give it as velocity. 3, we can say maybe displacement. Okay, so those are some of the examples. Yeah, even momentum, acceleration, those are what we call vectors. Okay, so I hope you have understood on this part and everything is clear. Okay, so if you have a question, please feel free to drop a comment in my comment section there. I will be able to respond. Okay, so now we can move to the important stuff, which we call laws of what? Laws which you need to know under this topic, so that you'll be solving questions. Okay, so we have 2 laws. Okay, so let me just say important laws to know. Okay, important laws to know. So these are the important laws to know. I'm sure these laws you learned them in high school. Yeah, so important laws, number 1 is we call it as a parallelogram. Okay, parallelogram. Then the second one is a triangle. So I'm sure some of us know these laws, and I'm sure you're able to explain what they really are. Okay, so this is our focus on this topic. Okay, so I'm just going to go into the main stuff. Yeah, so let me change the board. Okay, so let's start with number 1. Number 1, it is what? Parallelogram. Okay, parallelogram. So that is the parallelogram. So mainly parallelogram, it is the one which we'll be using to solve problems. Okay, so it is the one which we'll be using to solve problems. So each one of us need to understand the idea behind the parallelogram. Okay, so we say all force vectors or quantities obey this law. So imagine you have two forces. Let's say we have a force here. Okay, we have that force, and we also have another force. Let's say this is another force. Let's name our forces. So this is force B. Okay, let me start with A. This is force A, and this is force what? Force B. Okay. So now we want to find the resultant of these forces. So if you want to find the resultant of these forces, that's where we go about parallelogram. Okay. So the first step which parallelograms state is that you connect the tails. Okay. You connect the tail of this force and this force. So if you connect the tail, so we're saying this tail. Okay. So the first step, you need to connect the tail of both forces. So force A, let's say this is our force A. Let me just shorten the magnitude. This is our force A, and this is our force B. Like that. So you have what? You have connected the tails. Okay. So now here you need to use parallelogram law, right? So parallelogram law is that make a point here, right? So just assume it shouldn't even be that accurate. So you just say our point it is here. We have a point here. Okay. So we have a point here. Okay. So we have a point here. Then you make arrows to be both arrows are going at the same point between this part. Like that. Now the difference is that these arrows should be dotted so that you differentiate. Sorry. Like that. So I'm sure you're able to see. So those arrows should be dotted like that. Then the resultant which you are looking for should start from the center. I mean the point of contact where they were the tails of both vectors connected. From here up to the point which you have indicated. So that will be our resultant. So this is my resultant. Okay, so now you have done that and everything becomes simple. Okay, so just to remind you of something which you need to know under this parallelogram. So you know that this angle should be equal to that angle, even this angle should be equal to that angle. So opposite angles should be equal, and all if you add all these opposite angles, they will all add up to what? To 360. They will all add up to 360. Okay, so it means if you have an angle here, it is the same as an angle here. Then an angle here, it is the same as an angle here. Then these angles are equal. So that is important. You need to know that, right? Okay. So we proceed. Now to find that resultant, to find this resultant, you need to now erase everything here. You can erase everything, so just simply use this part, erase. Okay, like that. So that's when you now conclude that the resultant is coming from here. Okay, so we can even name that one as resultant, like that. So that is the resultant. Okay, so now there is a special case of the parallelogram. Okay, so that's where triangle rule comes about. Triangle rule, it is used on the parallelogram. Okay, after applying parallelogram rule, that's when you can use what? You can use triangle rule. Okay, so triangle rule says that. So let me just bring back. Okay, so parallelogram. So you have to take one of this one. This is a triangle, right? So even this is a triangle. So you get one. Okay, you want to calculate the magnitude of this one, the side, the angles, whatever. Yeah. So now you can use what? You can use that. So you can take one triangle here. So in my case, I'll take this one, but it's okay if you take this one. There is no harm. Okay. So I take this one. The triangle is up here. Okay. In this case, let me avoid the colors. Shorten the thickness. Okay. Then we also have another one like that. Okay, so I've simply taken the triangle which is on top there. Then you apply, say, let's name these vectors. So we have the resultant, we have A, then we have B. So what I've simply done is that you can, as you can see, this one, it is the same as what? This part here. So this is vector B, so it is just the same as this one. So that's where I've placed B on that vector. Okay. So now we can as well put angles here. So we put an angle there. So that would be angle A. Then this is angle B. And that is angle R. Okay. So that is angle R. Okay. So let me just say this is the angle here, this is the angle here. Okay, so those are the angles which we have. So now for you to apply triangle rule, okay, so to apply triangle rule, then I'm sure from here you're able to take it up, use those triangle rules. We have sine rule, we have cosine rule, those we have sine rule, and what? Cosine rule. So I'm sure you're able to take it up to apply those laws. So I'll just simply give the formulas which you need to understand. Okay. So if you take a look at this diagram, so we're going to say R, which is what? Which is the side. R. Sorry, I'm talking about the sine law. Okay, R over the what? Over sine small letter r. So the opposite angle to that side over sine what? Sine small letter r. We say it is equal to, we get another side, let's say side A, side A. Okay, let me do it on this part. Okay, over sine what? Over sine small letter A. Okay, over sine small letter A. Then we can also, it is equal to another side, which is B over, over sine what? Over sine B, small letter B, to be specific. Okay, then also, then let me display it here. Okay, so that is the formula for sine law. Okay, so we'll be using this one to find everything which we need given a side and the opposite, the angle. So we've been given the angle, even the side, we can work out everything which is given to us on this diagram. So let's go to the other one, the sine, this cosine law for cosine law. So on this one, sure you understand that from there we add the resultant. So we are looking for R. So the formula is simply R. Then let me use this one. Okay, so there's a square root going in that direction. Forgive me about my writing. Yeah, so it will be those two opposite sides squared. So opposite side squared as b squared. Then we say minus open. This is 2ab cos small letter r. Okay. Okay. So someone might ask, why is it that we are using r for when finding this one? Sure, you might have forgotten how we were finding grade in high school. Okay. So for this one, what you just need to know that you will be given two sides. You'll be given the value of two sides and the angle in between. What do I mean by that? So let's go back to the diagram. So you'll be given two sides A and B, and given this angle you can given. Then you ask to find the resultant. You can use that formula, which is which is the cosine law formula. Okay, so these are the important things which you need to understand on this topic. They are very, very, very important. Okay, so just a review, quick review on how you'll be solving problems. Okay, so number one, so let me just say steps in what? In solving force vector problems. Okay. Steps. So this will be just a review. So one is that you identify the unknowns. So identify the what? The knowns and unknowns. Okay, so that is the first step. Then the second step is that you draw a free body diagram. So draw a free body diagram. A free body diagram. Okay, and what? And label it. So it's saying label. Okay, so label it. Then the third one is that now you apply what? Parallelogram law. Then the fourth one is that you what? Apply triangle law or law. Then now on 5 you just applied what? Trigonometric law. So trigonometric. Okay, let me just say trigonometry. Then 6, now solve. Okay, you solve for the unknowns. So this is the simplest approach which you'll be using. So this is the simplest approach which one need to use. Okay, so this is the simplest approach one need to use to solve any problem. Okay, so for this class it was an introductory class. Yeah, so I'm sure in the next class we'll solve at least 1 or 2 questions based on what we have understood on this one. Okay, so I don't know if we can do 1 question, 1 or 2 questions. Let me see if I have a question. Okay, I think I do have some extortion. What else? So let me maybe I use a different. I have any. Okay, so it's saying choose. Okay. So I'm sure it's this one. Okay, sure this is question 3 from the tour sheets, from those practice questions. Yeah. I don't know if you can see, but I'll be reading it out. Okay. So the question is saying the force, the vector force F acts downward at A only 2 membered frame shown in the figure below. Determine the magnitude of the water of the 2 components of F. Of 2 components of F directed along the water, the axis of A and G, is AB and AC, if the force is given in those values. So the first one is given in the unit of Newton, then the other one is G. Okay, so on this one you don't even have to get worried, because you normally have to use the unit which you've been given. There's no need of conversion or anything of that kind. Okay, so let me just zoom in a bit like that. Okay, so to start with, we've been given, as you can see, there's a force here. We've been given a force. What else? You've been given the component of this force in SB and in what? In AC. Then you've been asked to find what? The magnitude of AB and AC. So here's the thing. Okay. So you need to make sure that you have a parallelogram to solve such problems. Okay. So one can look it at other sides. It's okay. If you just go, you can start, oh, this is a triangle, so we can take this force here, whatever. So I'm just going to go in the simplified manner. Okay, so I'm going to get this force. So as either we stated that you need to follow some steps. So you are free to follow those steps, but I'll just go into the main point. Okay, so we have a force here. So this is more like a resultant. We have a force here, and we have force AB and what? And AC. Okay, so those are the components. Okay, so now as you can see, we are trying to make a parallelogram. So let's make a point. So sorry, I'm using my phone to do these things. As soon as I buy a webcam, it will be easy. Yeah, so please kindly subscribe if this seems to be helpful to you, so that I might know that I'm not simply doing something, but I'm helping. Okay, so please support me by subscribing to my YouTube channel, so that you'll be notified as soon as I post a new video. Okay, so different one. Okay, so I've just simply gotten a point. This is a point from here. So from this point, this is the point. Okay, so this is a force F. Force what? Force F. Okay, so now we have a force again here, which is force AC. So might use a different color for that. Okay, so that is force F, this one from A to C. So force F, force A to C here, force AC in short. Then this one, we want to make a parallelogram, so we can just make a continuation here. Okay, we are interested in the force which is coming this side, so we forget about that side. So this force, we can take it in that direction, so from A to C. So I'll just simply there's a force which is there and there. Okay, so let me just name them. So this is force AB. So this is force AB, and this is force AC. Force AC. So what we have just simply we have connected the what? We've connected the point of the tail of this one. We've taken the tail to start from this point, going this direction, and the tail of this one at this point. Okay, so now we can further proceed. Let me just extend a bit. Now we can do our thing again. We connect this point and this point, even this point and this point. Okay, so now this point should be not being dotted for like that. So they are in dotted form. Now we can apply our laws to say, okay, the angle from here to here is equal to the angle from here to here, then this angle and this angle, they are also equal. Okay, so now as you can see, this question, the way they have phrased the question, okay, so they are saying, as you can see, force AB, which is force AB, then the line, so meaning that the line, this line and this perpendicular line is also at it's not perpendicular, but it is more like at a 90 degree. Okay, so it is pointing downward, vertically downward, so it's more like in the y-axis. Okay, so the angle here, it is 45, as you can see from there. Since we are saying, if we consider this line and this line, they are the same, so I mean the angle here, it is 45. So if it I'm sure I will so that is what is 45. So this angle is what is 45. Okay, so now after being given that is 45, okay, so this is 45. What about this angle? So from here you can see that if you consider this as the initial point, this as the initial point, and you consider this force, okay, so you've been given a Z here, so it's possible that you can make a Z here. Okay, so you make a Z here. So what I'm trying to say is that here you can make a Z. Let me just put like that. So meaning that the angle here, it is the same as the angle here. Okay, so the angle here, it is the same as the angle here. What do I do? Then we do calculation. So I'm going to put the force, the same force now on the free body diagram. So I'm going to put the force here. Okay. Okay, I put the force there. See, that force is the same. So that angle this angle is angle 30. Okay, so that is the angle 30. So now what do we do? So since now we know that that is angle 30. Okay, so you can see this line is making a 90-degree angle. So we are free now to calculate the angle, which is here. Okay, so how do we calculate that angle? So that angle, we just simply subtract 30 and 90, which I'm sure it should be 60. So about that. So that is angle 60. So our main point, our main thing here, we are supposed to find what? Excuse me. So we are supposed to find the angle here. Okay, so the total angle here, it is our main focus. So then we said the angle here, it is the same as the angle here. So what you simply do, you add 45 plus what? Plus 60. So it is giving 105. So 105 is simply the angle which is here. So let me indicate that it is 105. Okay, so this is angle 105. So now what do we do to find the other angle which are remaining here? So we said these angles are opposite, they are the same, but all the angle here they add up to what? To 360. So meaning that even the angle here and here they are the same. Okay, so the angle here and here they are the same. So we can just simply add this opposite angle, we subtract from 360, then we divide by 2. Okay, so simply add 105 plus 105, which is 210. Then you say 360 minus 210, it is 150. Then 150 divided by 2, it's giving what? 75. So meaning that the angle here and the angle here, they are both what? 75. So here we have 75. Even here we have 75. Okay, that's it. So now we can now proceed. Now to making a triangle here. Okay, so we make a triangle here, so we can either get this part or this part. So as you can see, this opposite side. So this opposite side, which is the same as this one. This one is also as this one. Okay, so we're just simply saying this is AB. So have AB. Then we also have AC. Okay, so now we can take one triangle from here. Which I'm going to take this one. I'll take this one as my triangle. Okay, so I'll take this one as my triangle. So let me just like that in the other part. Then I erase part. Okay, so that is our resultant. Then we also have the force which is coming this side. Then we also have force which is going that direction, like that. So let me name that. So I name that as, this is force A, this is force F, this is also AC, and we also have AB. That is force AB. What about the angles? The angle there, as you can see, we have 60. Okay, so we have 60 here, so I mean 60 is there. So we have 60 angle there. Okay, then here, as you can see, we have 75. Here. Then to find the other angle, we know that this 105 was connecting 2 points. So to find the other angle, just simply say 60 plus what? Plus 75. It is giving 135. Then we say 180 minus 135. So it's giving 45. So the angle here is what? 45. So the angle there is 45. Then say that is 45. So now we've been given force F in in part A, which is say take F to be 555. So 555 what? Newton. Okay, so please pardon me with my board. Soon I'll buy a WAPCO, which will be much easier to explain than this device I'm using. Okay, all right, so we now go to the other. So let me just erase everything since you have taken note of the important stuff here. Okay, so now we can go now to the application of whatever item we can have. So the application, now we got the what to the application. How do we go to the application? So as you can see, you have an angle on the opposite side. Okay, so this is the angle on the opposite side. So which of the sine law can we, and which of the trigonometric law are we going to use? So I'm sure you're able to understand that we can use sine law because you have an angle and what, and the force. Okay, so this one will go, things that's simple. So we have force AC, okay, we are trying to find AC. So let me just say 550 over sine 75 over what, sine 75. Okay, then say it is equal to, then we also have AC, which is the side, then the angle we use 45, sine 45, sine 45. Okay, so now we can find now AC. What is our AC? So our AC will be equal to, we just simply 55, 45, 45. Okay, then we have sine 75, sine 75. Like that. Okay, so now you punch in everything, find the value. So I have a calculator here. So you say 555 sine 45. Okay, then also have sine what, 75. So here it's giving me 406.2, let me just say 0.3 Newton. The force is Newton figure 4 Newton. So that is my AC. Then for my AB, we can just simply equate to everything here. It is equal to what? AB over what? AB over sine, AB over sine, excuse me. Okay, so now you simply equate this one to this one because we have all the required value here. It might be not that accurate if you use this one since you have found AC, but simpler use this one and this one. So my AB should be equal to that is 555 sine 60, okay, over what, over sine, okay, over sine 75. Okay, so we have AB being equal to, if you punch everything on a calculator, you say 555 sine 60 then sine 75. It's giving 497.6 Newton. Okay, so these are the required answers which they were asking for in the first part. So on the second part you do the same, only that you get to use the force 822 kips for the magnitude here. Then everything is the same. So this comes the end of this video. I hope you enjoyed it. Yeah, so please kindly subscribe if you feel like it was helpful. So end of class. Okay, end of class. So please do subscribe to my YouTube channel to avoid missing out the future videos which will be coming. Okay, so it has been the inorganic tutor. So my name is Joshua Skanika, but I'm known as inorganic tutor. All right. Thank you for watching my video. Yeah, please feel free to share with others. I'm sure it might be helpful to them. All right. Thank you. Have a wonderful day. All right.